Hello everyone. Today we shall discuss about the angle of contact, the physics of wetting and surface tension. At the intersection of a liquid, a solid and the air, a microscopic battle of forces defines how materials interact. This is an exploration of the contact angle, the definitive metric for adhesion, capillarity and wetting behavior. See, if this is a liquid of water, there are three phase contact line. This is the solid surface. This is the liquid. You can see if we draw tangent to the solid surface and the tangent to the this one. So this says what it says, the angle of contact. The angle of contact has three metric. One is for adhesion, one is capillarity, and the third one is wetting behavior. So let us find out how to find out the angle of contact. Here you see the spectrum of wetting behavior. Spreading, it is spread, the water is spreading, maximum surface contact, low angle, and this angle of contact is less than 90 degree. That is low angle. Angle of contact is less than 90 degree. But beading, or we can say it non-wetting, so it is circle. In this case, minimum surface area. It is maximum surface area of contact. In wetting, and in non-wetting, it is minimum surface area. And what you get? It is the adhesive force. In this case, adhesive force is greater than cohesive force. What is adhesive force? Adhesive force is the force between different molecules. Suppose this is the molecule of water. Suppose this is molecule of water. The attraction between the molecule of water and suppose there is a glass here, glass. So the attraction between the molecules of glass and that of water, and this attraction is known as force of adhesion. In this case, the force of adhesion is greater than the force of cohesion or cohesive forces. But in case of beading or non-wetting, it has first the minimum surface contact. The surface contact is minimum. You see, the surface contact is minimum. This is the surface contact, and it is minimum. In this case, cohesive forces is greater than adhesive forces, and high an angle of contact is greater than 90 degree. It is not in this case. It will be like this. It will be in this way. This is the surface area, and this is the another. So this angle is, you can see that it is greater than 90 degree. It is greater than 90 degree. And here you see this angle is less than 90 degree. This angle is greater than 90 degree. Greater than 90 degree. Therefore, in the case of if the angle of contact is greater than 90 degree, in that case cohesive forces is greater than adhesive forces. Cohesive forces means the forces acting between the same type of molecules. Suppose this is water molecules. The attraction between the water molecules is known as cohesive forces. And adhesive forces means the forces between different molecules. This is water and this is suppose glass. So the molecules of attraction between glass and water, and that is adhesive forces. In this spreading or wetting, adhesive forces is greater than cohesive forces. In case of beading or non-wetting, cohesive forces is greater than adhesive forces. And here the angle of contact is greater than 90 degree. That is, theta is greater than 90 degree. But in this case, theta is less than 90. Theta is less than 90 degree. And you see here, the behavior is governed by the balance of surface tensions at three distinct interfaces. Spreading occurs when liquid maximizes contact with the surface. Beading occurs when liquid minimizes minimizes contact, pulling on into itself, right? So we are getting the behavior is governed by the balance of surface tension at three distinct interfaces. Spreading occurs when liquid maximizes contact with the surface. Beading occurs when liquid minimizes contact, pulling into itself. And the next important thing is that of defining angle of contact. What is that angle of contact? Actually, the angle of contact is defined in this way as that the angle formed by the tangent to the liquid surface and the solid surface at the point of contact. The angle is always measured inside the liquid phase constraint. And you see, the angle formed by the tangent to the liquid surface. See, this is a point. So the tangent is here. This here is the tangent. You can see it. Here is the tangent, right, of the liquid, and the tangent of the solid surface is this one. So the angle between them, this is theta. This is known as the angle of contact. The angle formed by the tangent to the liquid surface and the solid surface at the point of contact, that is the angle of contact. The angle is always measured inside the liquid phase. Significance: the single geometric measurement serves as the proxy for how well a liquid for how well a liquid for how well a liquid adheres to a solid. This single geometric measurement serves as the proxy for how well a liquid adheres to a solid. This is the angle of contact. Now you can see here that third one is the geometry of meniscus. This is very much important. The geometry of meniscus. Liquid climbs the walls. When is this case? When theta is less than 90 degree. The angle of contact is less than 90 degree. And it is a concave meniscus. It is a case of weighting. If the angle of theta is the angle of contact is less than 90 degree, as in case of impure water, we got this that theta is less than 80 degree. In this case, the meniscus is concave and it is the weighting behavior. Liquid displaces away from walls. When the angle theta is greater than 90 degree. When angle theta is greater than 90 degree. So we are getting this angle. You see here, this is the tangent on the right. So in this case, liquid decreases away from pulse. It is the case of mercury actually. It is mercury. This is case of impure water. And if it is impure water, what will happen? In case of impure water, you can see here the geometry of meniscus. In case of pure water, the angle of pure water, the angle is equal to theta equal to 90 degree. And in this case, the surface is straight. This is pure water. Number case 1 is pure water. And number 2 is impure water. And number 3 is a case of mercury. So these are the behavior of meniscus. In case of pure water, there is no meniscus. The surface of the water will be straight and theta equal to 90 degree. In the case of impure water, it is the theta is less than 90 degree. And in case of mercury, theta is always greater than 90 degree. So it is non-weighting behavior. It is weighting behavior. Concave meniscus is formed when there is for that when theta is less than 90 degree. Theta is less than 90 degree. And for mercury, theta is greater than 90 degree. Now the next important thing we find it here is the acute case or theta less than 90 degree. Dominant adhesion. In this case, adhesion is greater than cohesion. Adhesion is greater than cohesion. Adhesion. What is adhesion? Adhesion is the force between different molecules. Adhesion is greater than cohesion. Cohesion is the force among the same type molecules. Suppose this is water. So the attraction between the water molecules and water molecules is known as cohesion. Cohesion. And suppose this is glass. So the attraction between the molecules of glass and water, this is known as adhesion. And if adhesion is greater than cohesion, this classification, good weighting, then good weighting and maximum surface of contact. Number 1 is good weighting and number 2 is maximum surface of contact. Maximum contact of surface. Maximum contact of surface. Maximum contact of surface. And forces, adhesive forces, attraction between liquid and solid. You see, this is liquid, what? Liquid, and this is solid. These adhesive forces overpower cohesive forces, attraction between liquid molecules. So in this case, adhesive forces is greater than cohesion. So it should be good weighting and maximum contact of surface. Benchmark, water on clean glass. This type of behavior. Data point typically exhibits an acute angle in the range of 0 to 80 degree, and this range is from 0 to 80 degree acute angle, and this is less than, this theta is always less than 90 degree, and if theta is less than 90 degree, then it is a behavior of good weighting and maximum contact of surface, and theta is less than 90 degree, that is here in this case adhesion is dominant adhesion. Next important thing is the obtuse angle theta greater than 90 degree, dominant cohesion. In this case, cohesion force is greater because the angle is greater than 90 degree. Classification poor weighting or minimum surface contact. This is number 1 is poor weighting and number 2 is minimum surface contact. Minimum surface contact. What you get? Cohesive forces, liquid, overpower adhesive forces, liquid, solid. In this case, cohesive forces is greater than adhesion. Benchmark is mercury on glass, this type of behavior, and theta is always greater than 90 degree. This is not theta, but this is theta. This angle is theta. This angle is theta, and it is always greater than 90 degree. So what you get? Data point typically exhibits an obtuse angle around 135 degree. So this angle is nearly 135 degree. Exhibits an obtuse angle around 135 degree. So the dominant cohesion. So here the cohesion force is greater than that of the adhesion force. Cohesion means liquid interaction. Forces among the liquid interaction. So what you get, that it is a poor weighting and minimum surface contact. Next one is the balance of interfacial tension. Triple point. Solid liquid. This is the solid liquid interface. This one is liquid air. This one is solid air interface. Solid air. This is liquid air. This is solid liquid interface. Solid liquid interface. The contact angle is a mechanical equilibrium between three distinct tensions. The tension between solid and liquid. This is the tension between solid and liquid, this force. And the tension between liquid and air, the tension between liquid and air, this second force. And the third one, SA, the tension between the solid and air, the tension between solid and air. And if you consider this as theta, then what we get that SL solid liquid is equal to SLA cos theta plus SSA means solid air interface. This is the formula we are getting for three interfacial tensions. SL equal to S LA cos theta plus SSA. Now you get from this you can find the various other things also. And the fourth important thing is this one, that is quantifying equilibrium, Young's equation. And this is Young's equation. From the above equation we are getting that cos theta equal to SSA minus SSL by SLA. This is a solid air interface. This is solid liquid interface. And this is liquid air interface. So you are getting this theta cos theta SSA minus SSL by SLA. The logic, the cosine of the contact of angle is determined by the ratio of the net solid surface tension to the liquid surface tension. Net solid surface tension to the liquid surface tension. The mechanics, this is Young's equation. This is known as Young's equation. And the equation represents the horizontal resolution of forces acting on the droplet edge. The horizontal resolution. So in the same case, in the previous case also, we get the same thing, that is this one, that SSL we are getting this equation, and this is the mechanics. And the next one what we get here is the decoding the equation. Here you see that if there are three cases, in these three cases, this is cosine is plus 1, this is cosine is minus 1, and cos theta is 90 degree. What happens? If solid air pulse is strong, solid air pulse is strong, the numerator is positive and cos theta is positive and the angle is acute. If solid liquid in resistance, solid resistance is strong, the numerator decreases, pushing angle toward obtuse. The 90 degree threshold occurs when adhesion and cohesion forces are perfectly balanced. When adhesion force and cohesion force are equal, then this occurs 90 degree adhesion. So these are the three cases. This is cosine plus 1, cosine 0, cos 90 0, and this is cosine 180, that is value is minus 1. Cos 0 is 1. You can write here cos 0 degree, that is the value is 1 plus 1. Cosine 180, that is value is minus 1, and cos 90, the value is 0 degree. So what you get, the 90 degree threshold. So these are the three factors we are getting it here. Theta is less than 90, one is theta is 90, and one is this is theta is greater than 90 degree. This is the case of mercury. This is the case of pure water. Pure water. This is of mercury, and this is of impure water. Impure water. So this type 3 questions decoding the equation. And the next important thing is this one, that is variable one, the impact of impurities. Mechanism: adding impurities changes the chemical nature of the liquid. Effect: agents like soap decrease the surface tension. Adding impurities changes the chemical nature of the liquid. Effects: agents like soap decrease the surface tension. Result: a decrease in surface tension leads to a decrease in the contact angle, effectively increasing wetting capability. This is why we wash with soap. This is why we wash with soap. This is the reason, impact of impurities. And the next one is this one, the impact of temperature. Thermal energy. Heat alters the kinetic energy of the liquid molecules. If at increasing temperature typically decreases the surface tension. Increasing temperature typically decreases surface tension. Contrary to intuition, this decrease in tension often results in an increase in the contact angle, leading to less wetting at higher temperature. Less wetting at higher temperature. So this is cool, this is hot behavior, right? So this is important, the impact of temperature, that increasing temperature typically decreases surface tension. Contrary to intuition, this decrease in tension often results in an increase in the contact angle, leading to less wetting at higher temperatures. And the third one is summary of wetting states. Angle theta is greater than 90 degree. Acute case, when angle is less than 90 degree. This is not this is when angle theta is less than 90 degree. Angle is less than 90 degree. So in good wetting spreads. Concave meniscus, U shape. An example: water on glass 0 to 80 degree. Water on glass. Obtuse angle, if angle is greater than 90 degree, poor wetting, beads. Convex meniscus, inverted U. And example: mercury on glass 135 degree. This is angle is 135 degree. This angle is 135 degree. And this angle is acute 0 to 80 degree. 0 to 80 degree. Acute angle. And the most important next in conclusion, you can say that this one, the implications of the contact angle: adhesion, porosity, nature, coatings. That is, understanding the contact angle is not just an exercise in geometry, it is a fundamental measure of adhesion. It predicts how fluid move through porous materials, how coatings stick to surfaces, and how capillary action functions in both nature and engineering. The angle theta tells the story of the molecular forces hidden in plain sight. So this is the overall influence of the angle of contact. Thank you everybody for watching this video.